Hello friends, welcome to Independent Learning. My name is Raj Shah, and in this video we are going to continue with the chapter Basic Concepts in Geometry. Okay, in the previous video we saw how to find the coordinates of a point and the distance between them, and also we saw what is betweenness. Now in this video we are going to continue with the chapter, and in this video we are going to learn about the basic concepts: what is line, what is a segment, and what is a ray in terms of a point. Okay, we'll learn about what is intersection and union, which you have already done in the chapter which is sets of algebra. Okay, and also we'll be learning about when the segments are congruent, or we are going to compare with the segments, and also we are going to see if the lines are perpendicular to any segment, how and what are the properties or what are the characteristics which are involved in when the two lines or a segment and a line is perpendicular. Okay, so let's see them one by one. Okay, now before starting with what is a line or a segment, let us see what is union and intersection. Okay, so you might have already done this in algebra. Okay, so this is union and this is the sign for intersection. Okay, I'll write that, and this is so. Without wasting much time, we'll just look what is a union and intersection with an example, and then we'll start with our topic. Okay, so if we have a set which is having three elements, which is 1, 2 and 3, and also another set which has element, let's say 3 and 4. Okay, now what will be the union of these two sets? So it will be written like this: A union B. So union means involving all of them, which is 1, 2, 3 and 3, 4. 1, 2, 3 and 4. Now if you see, I have not repeated 3 because in a set you don't repeat, correct? So A union B is writing all of them together but without repeating. So that is union. Now let's see what is intersection. A intersection B. Now intersection says what is common. So you can say right over here, everything together without repeating. And for this we can say common things, or you can say just common elements. So in set A there are 3 elements, in set B there are 2 elements. We saw how to find union, writing all of them together without repeating any of the element. And then let's see what is intersection. Common elements. So from A and B, what is common? The only element which is common is neither 1 or 2, it's just 3. See, correct? So we'll just write this here: A intersection B is 3. Okay, so this union and intersection will be used in the concept which we'll be learning now about what is a segment, what is a line and what is a ray. Okay, so let's continue with that now. So let us see what is a segment. Okay, the first topic. Okay, so what is a segment here? Now if let's say there are 2 points, okay, A and B. Okay, now when I join this, there will be a lot of point which will be there in between, so I'll just join it. Okay, so this is the segment. Now what is a segment in terms of points? If you see you already know what is a segment, what is a line and what is a ray, but here we are learning this in terms of points. Okay, so we're describing segments, line and ray in terms of points. Okay, so here if you see, point A and point B are the two extreme points of this segment. Okay, union of so segment AB, if you say, let's say name this is, we are discussing about segment AB. So segment AB will be defined as union of point A and B. So there is A and B involved together, and also all the points between A and B. So all there are n number of points here in between A and B. Correct? Therefore, we are taking all of them and we are taking the union of all the points, including A and B. So that is our segment AB. Okay. So segment AB is the union. So that's why we discussed what is union and intersection before starting with this topic. Okay. So union, taking all of the points together in one set. So that is segment AB. Okay. I hope you understood. Now the other thing, which is the second, is a ray. Okay. Now ray is okay, there is a segment, but okay, so there was this segment AB. Okay, we included some more points, okay, and we drew an arrow here, just like that bow and arrow. That arrow here, in that bow and arrow, that arrow itself is called a ray. The AB is union of all points on AB and Q. Okay, so union of all points on AB and Q. Okay, such that A, B and Q. So this ray is forming a betweenness with B in between A and Q. So we are mentioning that also. So all the points from A till here, till end point, ahead of Q also till here, is, and union of them is called a ray. Okay, so that is a ray. Okay, now let's see what is a line. Okay, so from segment and ray, line is derived. Now if you have segment AB already, segment AB, then there is Q. So from point A, if you ignore this part, okay, from point A to Q, or this part, is ray AB. Correct? Now if I draw this ray itself on the opposite side also, so it will become something like this with P, point P. Okay, so here now this will be called AB here. From this part, this will be a ray from here if you ignore this part. So here AB is the ray, here also AB is the ray, but this side if you see, BA is the ray from this side if you see. Okay, so by union of ray AB, okay, so this is ray AB till here, from this point to this point. Okay, so that is union of ray AB and opposite. So you take the opposite of ray AB. Okay, so that is this ray. So opposite of ray AB. Okay, and opposite of ray AB. Okay, opposite of ray AB. Opposite ray of ray AB. So you draw this ray is there, AB is the ray, and you draw an opposite to the ray AB. So that is also included. Okay, that is called a line. So I'll repeat it once again. Line is what? Union of ray AB. So there is this ray, okay? This is there, and there is an opposite ray of AB. Okay, so you draw an opposite ray of ray AB, which is BA. So here, how do you pronounce a ray, or how do you call a ray? So this A is called, A is the end point. So from the end point, you call this ray, or you name this as ray AB. Okay, and here for this you can say this line is composed of ray AB and ray BA. So BA will be like this. So from B till A, or you can say this is the ray. Okay, so that is a line. So we'll see what are congruent segments. Okay, so let's say there are two segments AB and CD. Okay, so if there are two segments, okay, so why are they, can they be called a congruent segment? When will they be called? If the length AB, okay, length of segment AB is equal to or congruent to length, let's say it's equal, if the lengths are equal or congruent, then we can say segment AB is congruent to segment CD. Okay, you can say this as equal or congruent, it means the same. So if the length is congruent, if their lengths are congruent, then the segments are congruent too. Okay, so I hope you have understood. Easy. The fifth one, which says, we are going to discuss this now, which is reflexivity. Okay, so that is reflexivity, then symmetry, the second, and the third okay, so third one is transitivity. So we are going to discuss what is reflexivity now. Now before starting with this, just imagine you looking yourself in the mirror. So if you look yourself in the mirror, what will you see? You'll see yourself. Therefore you can say that you are the same person as you look in the mirror. Correct? Am I making sense? Let's see how it is done in terms of segments. So it is segment AB. If I consider any segment, let's say it is AB, then that will be congruent to that same segment. Okay, so the example which I took, if you look yourself into the mirror, okay, so you see yourself, right? So you are the same person as you look in the mirror. So you are congruent to the person looking in the mirror, or you can say the person who is seen in the mirror. So that's why it is same. Reflexivity is derived from that only. Okay, segment AB is congruent to that same segment. Okay, so that is reflexivity. Then what is symmetry? Now for understanding symmetry, I want you to understand this. Let's say this is a rectangle. If I cut this into half, okay, if I cut this into half, this is being cut, okay, the rectangle is cut into two halves, they both are same. Okay, I have divided the rectangle in such a way that this part and this part, they both are equal. Getting? Then what is symmetry in terms of this? If I say that this part is equal to this part, then we can also say that this part, so the second part, is equal to the first part. So what did I say? If the first part is equal to the second part, then the second part is also equal to the first part. I hope you understood. What can we say? If segment AB is congruent to segment CD, then okay, if the first one is congruent to the second, then the second one will also be congruent to the first. Okay, that's the main point of symmetry. So then segment CD is congruent to segment AB. Okay, so this is what symmetry is. Then the third one, which is transitivity. So let's see what is transitivity. Okay, so we'll take here AB, then let's say CD, then XY. Okay, so transitivity says if segment AB is congruent to segment CD, okay, and segment AB is congruent to CD, and segment CD is congruent to segment XY, okay, then segment AB is also congruent to segment XY. Let's understand this with a simple example. Let's say this is the video which I'm recording. Okay, if I share this video to you, okay, and this video is shared by you to your friend. So what is happening here? I shared this video to you, and you shared this video, which was shared by me. You shared it to someone else. So what is happening here? So can I say that I shared to that third person? So I'm the first person. I shared the video to the second person, which is you. Okay. Then you shared the same video to your friend, to one of your friend. So if that is happening, that means I shared to you and you are sharing to your friend. That means I am sharing the video to your friend. Can we say that? Because through you, of course, through you only. But I'm sharing it to your friend also through you. So that's what transitivity is. If AB is congruent to CD, okay, and CD is congruent to XY, then AB is congruent to XY. Same way how I am sharing the video to your friend through you. So AB is congruent to XY through CD. That's what transitivity is. Okay, I hope you understood. So we'll see what is midpoint of a segment. Okay, so the sixth topic, midpoint of segment AB. Okay, so what is the midpoint? I will see the property of it. Let's draw a segment AB. Okay, so let's say, okay, let's name this as Z. Okay, so let's name Z as the midpoint. Now what is the property of midpoint? So if AZ, okay, if AZ is congruent to ZB, okay, this is segment, okay, segment you have to write. Segment AZ is congruent to segment AB. If this happens, then we can say then Z is the midpoint of AB. Correct? So if AZ and ZB, they both are congruent, then we can say that Z is the midpoint of AB. Okay? So let's see. So I hope you have understood this. Another concept, which is comparison. So we'll compare segments. So comparison of segments. Okay, so comparison of segments. Let's see. So let's draw AB and XY. Okay, so there are two segments, segment AB and segment XY. Okay, Now comparison means what? Which one is bigger and which one is smaller. Okay, so here the length of AB, okay, is greater than the length of XY, correct? So what can we say about this? We can say that segment AB is greater than segment XY. Okay, so we can say that segment AB is bigger than segment XY. Okay, so that's what comparison of segments is. So here we are saying what is perpendicularity, the eighth topic. So perpendicularity of segments or, okay, perpendicularity of a segment of segments or ray. Okay, so let's say if we have a segment which is AB, okay, so if you have a segment AB, okay, then what is perpendicularity? It says that if you draw a line, let's say this is C, this is D, okay, we have drawn line CD, okay, so if this is the case, if this line CD is perpendicular to the segment, so perpendicularity is segment AB is perpendicular to line CD. So let's write that also. That's what perpendicularity of segments is. So segment AB is perpendicular, okay, perpendicular to line CD. So this is the line, that's why line CD. Or you can also write segment AB is perpendicular to ray CD. So if you consider C and D, so instead of line we can also call this a ray. So ray CD. Okay. So this is what perpendicularity of segments or ray is. Now let's see the last concept. Okay. And then after that we'll solve questions based on the concepts which we have discussed till now. Okay. So the last one is distance of a point from a line. Distance of a point from a line. So there is a segment, okay, or you can draw a line out of this. So there is a line. Distance of a point from a line we want to find. So let's take any point. Let's say there is a point which is Z here, anywhere on this line, above the line, okay. Then to find distance between this point and the line AB, okay, can we draw this? Can we check? Can we take this distance? Okay, can we take this distance? No, of course not. Not even the other side. Not even like this or this. So we can only take the distance which is the perpendicular distance. Okay, to find distance between this point and the perpendicular, or you can say this line, will be, let's name this as P. Okay, now this P is what? P is called, okay, P is called foot of the perpendicular, because whenever you want to find the distance between a point and a line, you always draw perpendicular to that line. You cannot take any line like this. You cannot take any other line. You are always supposed to take a perpendicular line. Okay. So foot, P is the foot of the perpendicular. Okay. And therefore what are we finding? Distance of a point from a line is ZP. So ZP is the distance of a of point of a point Z to line AB. Okay, let's take one more example. Let's say this is PQ and this is any point X. How can we find the distance of this line and between this point? It will be this. We cannot take a slanting line, right, as a distance. This will be more, right? We don't want to cover more distance by walking, or you can say. So it's always a line which is perpendicular. So distance, we can say this is A. So AX is the distance, okay? Or you can say is the distance of a line, of a point from line PQ. You can write this as line. Okay. So I hope you have understood what is how to find distance of a point from a line, and also you understood what is perpendicularity. Okay. So now, based on whatever concepts we have done, we'll see questions based on them. Okay. So let's see them one by one. So we are looking at some questions now. So the first question, okay. So here the points are given to us and its coordinate is given to us. Okay. So this is point A, B, C, D, E, and the coordinates are given. Okay. We have to say whether these two are congruent or not. Segment DE and segment AB. Now you know this is to find segment DE, the distance. Okay. Distance of DE. We have done this in the previous exercise itself. So if you haven't checked that, please check that video and then come to this. So distance DE we need to find, which is, so E, or you can say E minus D. It's like coordinate of segment DE or distance DE will be coordinate of E minus coordinate of D, as discussed in the previous video. So I won't write that, we'll write the numbers directly. So it is 9 minus D, coordinate of D. So coordinate of E is 9 minus coordinate of D. So minus coordinate of D is this, minus 7. So minus into minus plus. So 9 plus 7 is 16. Okay. Now let's check for this distance AB. So this will be coordinate of B minus coordinate of A. Okay. So coordinate of B is 5. So 5 minus 3. Okay. So this will be 5 plus 3, which is equal to 8. Now if you see, are they two equal? No. Therefore we can say segment DE is not congruent to segment AB. Okay, segment DE is not congruent to segment AB. So M is the midpoint of AB and AB is 8. So this whole distance is 8 given to us. We have to find AM. Now you know AM plus MB is equal to AB. Why is this so? Again, by betweenness, you know AMB, because M is in between A and B, that is betweenness. Therefore, and you know that if M is the midpoint, we can say that AM is congruent to MB, correct? This AM and MB, they both are congruent. Therefore, we can substitute AM as MB, or MB here can be written as AM. Therefore, AM plus AM is equal to AB, because they both are same. Therefore, this will be 2AM equal to AB. What are we supposed to find? AM. What is AB here? Given to us that it's 8. So this will be 2AM equal to 8. Therefore, AM is 8 by 2, which is 4. Okay, I hope you understood. Because M is the midpoint, they are equal. Okay, and by betweenness we know that AM plus MB is equal to AB. So we replace MB with AM because they are congruent. Therefore add them, so you get AM ka answer. Okay, so that is this. Let's see the third one. What are we supposed to find? Write a pair. Okay, write a pair of points equidistant from point Q. So point Q is there here. Can we write a pair of point which is at equal distance? So if you see R and P, the distance between RQ and PQ is what? Let's find distance RQ. Distance RQ is coordinate of Q minus coordinate of R. So minus 4 minus of minus 6, that will be minus 4. Minus 4, minus into minus is plus, so plus 6. So this will be 6 minus 4, so 2. Now let's find distance QP. That will be coordinate of P minus coordinate of Q. So minus 2 minus of minus 4. That will be minus 2 plus 4. So 2 again. Now if you see RQ and QP, they both are same, which is 2, 2. Therefore, what can we say for this now? That point R and point P are at equal distance from Q. So we can say, what is the pair of point? The answer will be point R and P. Point R and P are at equal distance from Q. Okay, so that's what. Can you think of any other point? If you see Q, there is R and there is no other point here. So we cannot say any other point which is equal distance, at equal distance actually. So let's take one more question and we'll end this topic. So we'll take one more question here. Okay. So here this is given to us, this line, or you can call a ray. Okay. This is given to us and these are the questions which we need to find based on this. Okay. Now opposite ray, the first one which says opposite ray, so we have to write opposite ray of ray RP. So ray RP first of all is this, see RP, so you can RP, so ray RP is this, correct? Now what are we supposed to find? Opposite ray of ray RP, so opposite of RP will be what? RS, correct? So we can say for this, the first one, the answer will be ray RS, correct? Because RP ka opposite ray, so opposite ray of RP is RS, which will be like this. R, S and T. So opposite of RP is RS, correct? So that is the first one. Then comes the second one which says intersection of ray PQ. So PQ is this and ray RP. So intersection of PQ and RP we need to find, correct? So if you see, intersection of this will be, if you want to draw ray PQ first, let's draw. This is P, this is Q, and ray RP, that will be, okay. So intersection of ray PQ and ray RP, without even drawing the diagram, you can come to know that PQ is this part, okay, this is the ray PQ, and ray RP is this whole, correct? So what is common between this and this? Because intersection says that common thing we have to take. So the common part between ray RP, between this and this, is just ray PQ, correct? So we can say ray PQ, correct? So if you see this diagram, now union of ray PQ and QR, so PQ and QR, so See, you know that if 1 2, okay, and so if this is the case between two sets, we can say that A union B is what? It's just B itself, correct? Because 1 and 2 are included in both. So we can say A union B is just B, or you can say 1 2 3, which is simply B, the set B itself. Same way here also, to find union PQ and QR. So union of PQ and QR will be QR itself, because PQ is common in both, in QR also. It's present in QR also. See, QR, it is there. PQ is also there in QR. Therefore, we can say the union of this will be ray QR. Correct? Same way like here, A union B, B is the bigger one. We can directly say this as equal to B itself. A union B is B itself. Same way, this we are doing. Okay? Let's see the fourth one now. So the fourth one, ray of which QR is a subset. So QR is where this QR, the rays of which QR is the subset. So we can say, now you know that any set is a subset of itself. Therefore, first of all, we can say the answer for this, QR is a subset. So which ray is a subset of QR? So we can say that same ray itself, correct? So QR, okay, so which ray? QR is the subset of QR itself. And also can we say RQ, correct? RQ, because RQ is the subset of QR, correct? Because QR, because you know what is a subset? Something which is a part of that set, correct? So QR is a subset of RQ also. So this is RQ, so QR is also a subset of this. Okay, so I hope you understood. Then the fifth one, which says pair of opposite rays with common endpoint R. So common endpoint, point is R is over here. Pair of opposite rays. Okay, so we can say RP and RS. So opposite ray will be with common endpoint R will be RP and, oh sorry, we can write ray RP and ray RS. And also can we say ray RQ and ray RT? We can also say that. So you can say RQ and ray RT. Okay, so that is pair of opposite rays with common endpoint R is the common endpoint here. So RP is the one of the ray. If we take, then RS will be the opposite ray. So there is a pair which is formed. Same way for this also, RQ and RT. Okay. The next one, which says write any two rays with common endpoint S. So common endpoint, which is S, can be written as ST. Then we can say, sorry, ray. This will be ray ST, and we can say ray SR. So any two you can write these two, or we can say RSP and SQ also. Okay, because endpoint is same, S, which is S. Therefore, this is what it is. We can write more of them. Okay, which is SP and SQ also. Then the last one, which says intersection set of ray SP and ray ST. So SP and ray ST. So the intersection between SP and ST, let's draw it here. So if you see there is no common point. See, I mean, there is nothing common in terms of ray or a segment. So what can we say? Intersection set of ray SP, which is this, and ray ST, which is this, ST. Therefore, the common thing is only point S. So we can say for this point S, because S is the only thing which is intersecting, means which is common for these two rays, SP and ST. Okay. So I hope you have understood this question. So this was the last question for this topic, and we end this topic here. Okay. So in this video we learned how to find the concepts of line, segment, ray, and we saw what are congruent segments, then their comparison, reflexivity, transitivity, symmetry. Okay, we saw perpendicularity also, and we saw how to find distance between a point and a line. Okay, and we saw questions based on all those concepts which we discussed. Okay, so in the next video, okay, we are going to study about how to find a statement, what is a statement, and how to find its converse. Okay, so I hope you have understood the concept which I taught. Okay, so if you have understood this, make sure that you share it with your friends. Okay, thank you for watching.